So, hello guys, how are you? Thank you for sticking by to the end. Today we're gonna go with some huge marathon of all of my courses because thankfully our professor left us early this time. So I have time 1 hour and a half only to learn something new and to do it once again, and of course to explain to you guys if you'd like it. But I'm so sorry, but I have to close this item. Okay, thank you. So I can charge my phone. Sorry guys, blah blah blah. Okay, so let's begin with the Karnaugh map. Okay, map. The last time we saw application of Boolean logic, some identities to circuit design. The basic Boolean operations are and or not. These operations can be combined to form complex expressions, which can also be directly translated into a hardware circuit. Boolean algebra helps us to simplify expression and circuits. Today we will look at the graphical technique for simplifying an expression into a minimal sum of product MSP to that form. Of course, there are minimal number of product terms in the expression. Each term has a minimal number of literals. Circuit-wise, this leads to minimum two-level implementation, as you can see here. Okay guys, let me check this one because I want to be cool. Laser, come on. Oh, because I cannot edit it. Okay. Oh no, I don't like this. Sorry. Okay, so and do this one, so I'll try to be like cool, you know. Okay, we like this. As you can see here, we have the x prime, which means this is a negative. Yeah, this one here. Okay, y is not right. Oh my god, what's wrong with this? Nope. Okay, sorry, just no problem, just go ahead. Okay, so we have the x prime, which is x negative of 61 means 0, this 0 is 1, and we have here AND gate x prime z. To here we write here x prime z multiply together, x prime z prime multiply together, and on the other AND gate we have x y prime z, and we have to write here the expressions. And later on, we'll write here x prime z times z prime plus x times y prime times z. Here, because we have an OR gate here, A and B output. And here we have one output, which is the combination of the plus sign for x prime z prime and the plus x y prime z, zeta. We have the standard forms of expression. We can write the expression in many ways, but some ways are more useful than the others, of course. We have SOP, sum of product, and POS, product of sums. And the sum of products expression contains all the OR sums operation at the outermost level. Each term has the sum must be a product of literals. F of x, y, z is equal to y prime plus x prime, y, z prime plus x, z. As I can see here from my I cannot go any further with it because this is directly there. I cannot simplify it more. Yeah, let me see. No. Okay, yes, it is. The advantage is that any sum of product expression can be implemented using a two-level circuit. The literals and their complements on the 0th level, AND gates at the first level, and single OR gate at the second level. This diagram uses some shorthands. Not gates are implicit, literals are reused. As you can see here, y prime plus directly with an OR gate there to the input, but we have used two OR gates, and the first OR gate, two AND gate, and the first AND gate we have put the three output inputs with the x prime y, z prime, and the second AND gate we have x and the times z. And the function here will be y prime plus x prime times y times z prime plus x times z. It will be the function of this illustration here. Easy. Okay, the mini term is a special product of literals in which each input variable appears exactly once. A function with n variable has 2 to the power n mini terms, since each variable can appear complementary or not. a three variable, of course, functions such as f of x by z, and 2 to the power 3 mini terms, 2 to 4, 2 8. We have over 8 mini terms. We have here over x prime, y prime, z prime, blah 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 blah. And each mini term is true for exactly one combination of the inputs. You have to the mini terms. And this is true when the x is 0, blah blah blah, sure, yeah, m0, m1 to the m7. I'm sorry guys, but I have a toothache here, so if I might have got a sleepy, like, short-handed, I'm so sorry, because my, the teeth, my tooth, it really hurts. I have a toothache, I cannot bear it. I'll try to get removed tomorrow, hopefully, because after this COVID thing, everything is closed right now. So before see, I can't even talk right because it hurts. Okay, every function can be written as a sum of minterms, which is a special kind of sum of products form. The sum of minterms for any function is unique. If you have a truth table for a function, you can write the sum of minterms expressions by picking out the rows of the table where the function output is only one. Blah 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 0 0 0 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 0 1 0 1 1 1. Let's see here. Let's do it. So I can see here. I can highly see the simplification here. I can simplify the x prime, y prime, z prime plus z, which gives us 1. Let's give us this thing here, and then let's check the second expression here. We got directly here. X prime, y. X prime y give us z plus z prime 1 with x prime y. I can directly simplify x here with this one, so let's add this one here. It's so easy, guys. Okay, they have to rearrange the truth table, the two variable function as for possible minterms. You can rearrange them by these minterms in K-map. 0 0 0 0 0 0 0 0 0 1 1 0 1 1. And now we can easily see that each minterms contain common literals. The minterms on the left and the right sides contain y prime and y respectively. The minterms in the top and bottom rows contain x prime and x respectively. Oh my god, it hurts, like, oh my god, I cannot. The truth table to K-map. Let's do it with this with the AB input and the P here in the function. It will give us the result. 0 0, it is 1, which means we have a not. 0 1 give us 1, we have an AND, 1 0 AND. Yeah, the second one 0 1 give us the OR. 1 0 means an AND, 1 1. You can do it directly with an OR, no problem, or AND. To give us 1. So let's check it. Write it in the table. A in the vertical and B horizontal. So let's check this. It's from 0 and 0. We have here the 1, okay, and the 0, 1, A 0 and B is 1. We have 1, okay, and when A is 1 and B is 0, it is 0, and when A is 1 and B is 1, we have 1. So let's group this one. Don't forget, because my professor really don't have brain at all, and I'm so sorry about this one because I cannot write it. Don't forget this one, okay? Thank God. Don't forget this one, okay? Because we only use 2, 4, 6, 8, not 3. We cannot group this. 3 of them out. We can only group 2 in this case. Only like this. We cannot group it together because this is wrong, okay? This is what my professor said to me, but they are completely wrong. Okay, it's perfect. Let's go to the next. The JSON 1 can be paired off. Any variable which is both a 1 and 0, this pairing can be eliminated. The pairs, of course, may be adjacent horizontally or vertically. It's a set A and B here. Okay, B is negative, even A is the interm, so we don't have the truth table here, but we can do that right here. So with the A's, okay, let me A B. Sorry about my like this. Even while I've been working online classes, it's still worse. Okay, when A is 0 and B is 0, the output would be 1. And when A is 0 and B is 1, the output would be 1. Okay? I think this is like the worst one, so that's why I'm getting wrong. So let's do it, okay? When we have 1, when A is 1 and B is 0, it is 0. Okay? And when A is 1 and B is 1, we have 1. As you can see here. Yeah, and you can see here from the illustration, we have only done 2, 4, 8, sorry, 6, 8. Okay, I cannot do it anymore though. 2, 4, 6, 8. Okay? Don't group them all the three together because it is wrong. Don't do it. Okay, only use 2, 4, 8, 6 and 8 pairs. Only the power of 2. And let's imagine the two variables of Minterms, x prime, y prime, plus x prime, y. I can directly here simplify just by looking at it. I didn't see this one, okay, sorry, I didn't see this one. I could simplify it right here to give y prime plus y. This one is simplified because as you know from the identities, y prime plus y would give us 1. So that's cool as hell. So we're only left with x prime now, because x prime times 1 is still x prime. But this guy here, because he thinks he's smart, he's done the short way. He's done with the K-map. And let's see the result is the same. This guy here has done with the Boolean algebra, as I said before, because it's the harder way. This is how the cool guys do it, so you should learn it as hell, fast as hell. It's the same result, but it only depends by you. But I use the K-map too because this is easier. Another example expression, x prime y plus xy. Oh, I can directly here check the y and the x prime plus x. This is directly one. I'm only left with y. How about the blah blah? I don't have time for this. Never mind. There is also x prime y plus xy on the right side corresponding to y. All this expression can be do x prime plus y. Yeah. I don't have time for this, but can I write this case? No, only of this? Okay, not this one. Sorry. So I don't have time. For the three variable expression we put x, y, z, the arrangement of the Minterms is more tricky. Why so? We have a lot of ways to do K-map, but my professor is a D-head or a-hole. I don't like him. Hopefully this semester goes by really fast because he really doesn't know how to teach. I'm not trying to do anything against him, but he really doesn't know how to teach. Because the PowerPoint presentation is done by the Harvard guys from Yale, you know? Not from someone who finished school in Macedonia or something. But never mind, never mind. We'll try to do things really carefully and safe here. Of course, it is trickier. We can use x and yz. You can use it yz and x here. But don't forget, we only use 0 and 1 here. Combinations. Don't forget that one. We have 0, 0, 0, 1, 1, 1, and 1, 0. Let's do it right here. We can check which are the same expressions. Later on we can simplify it. This is the purpose of K-map. Of course, we have another way to label K-map. We can use whichever you like. X, Y, here and Z. X or like this. X, Z and Y. But don't forget, as I said before, we have 2, 4 or 8 adjacent. We cannot order 5, 3, or 11 because it is not allowed. It's a K-map rule. If even though it is real easier, we still cannot use it. And don't forget the spaces. Don't forget the spaces because they are important too. Squares on the map contains common literals that can be factored out. Blah, blah, blah. I can do it like yeah, it can be done like this. The Z sign. You know, you can use it with the harder way, as I told you, but I don't have time to be honest. I don't even have space at least. So let's go with it. So x prime z y prime plus y. These are so easier. Come on, x prime z. For Christ's sake. So guys, I'm pretty sure you know this one, so don't even mind to watch this video. If you know this one, it's so easier, but if you don't, no problem. Just stick to the first one and to the end, because to the beginning to the end, because this is so easier. Come on guys, I know you can do it. The adjacency equals revenue around the left and right sides with an x, perfect, and a y. And we're all left with a z because this is perfect K-map. Why? This is why we love the K-map, because they give us x z prime. This is simplified, simplified, simplified. Yes, as you can see here, this is simplified like this, prime, blah, blah, and you get x and y. This is done by this and this. You only left with this now, with a y prime and y. I see. Make it down to x, no problem. It give us the result. You can choose x here, no problem, but still get simplified. And we only left the z prime because, as you can see here, you can factor it directly here, but easier. You can use its already adjacent squares to justifications. Let's go simplify next f of x by z, x, y, blah blah blah. First you should convert expressions, if not already. The easiest way to do this is to make a truth table for function and then read it off the Minterms. You can either write out the literals, so the Minterms shorthand, the truth table. You can also convert the expression to a sum of Minterms, but boolean algebra, use by the blah blah. This is directly xy, y prime z, xz, so let's simplify it, blah blah blah. You're gonna have your x, y, z. Yes, I don't think that can be simplified way more than this, this is okay. In both cases, we are actually simplifying our example expression, the result expression, the larger than the original one, whatever individual Minterms makes it easy to combine them together with K-map. That's why we use K-map. Next up is draw and file in the K-map, put ones in the map for each time and zeros in other squares. You can either blah blah blah. Oh really? Only this, as you can see here, we can use here, here. You're gonna fill yes, as I said, that's a DD from the beginning side. Of course, we can fill the truth table here just by checking the K-map. 0, 0, give us directly there. Don't forget, it is so easier, guys. Don't forget to complicate things. Zeta or epsilon, yeah, to the end, blah 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 blah. 0, 1, 1, and 1. Because look, we have it 100. Because a and z is 1. This gives us an implication. Maybe it might be x times z. Who knows? Yes, it done this. You find this. So don't let me know more simplified. Okay. When x and y is 1, give us 1. When all of them are on, 1 means 1, we gives us 1. This one. The most difficult step is to group them together, of course. All the ones in the K-map make rectangles around a group of 1, 2, 4, or 8 ones. all the ones the map should be included at least one rectangle, not included means zeros. Yes, because zeros is the worst. We do not. Okay, why did I do that? Because it is important. You should learn it. We don't have to include any zero because single zero means a lot of problems. Zero is off. Zero is we don't like zero at all. We hate zeros. It depends because zero will be important in the near future. No problem. As I said before, don't forget we use 2, 4, and 8. So each group corresponds to one product term for a single result. We have to make, of course, fewer rectangles possible. Make each rectangle the largest one. Yeah, I forgot. We only group by the largest one. Whenever we have the largest group of 2, 4, 8, we only use the largest one we have. If it is 8, we use 8. If it is 4, we use 4. If it is 2, we use 2. Only by the group we have. It is all the right for rectangles overlap, of course, if that makes them larger. You can find the MSP to amongst getting this message here from school. Hopefully it's never mind. MSP I forgot, sorry. MSP was like okay, well, no problem, I found it. Cause okay. We are at 17, right? MSP minimal sum of products. MSP is minimal sum of products. And let's do it all. Yep. MSP is the minimal sum of products. And for example, we can find that x and y plus x y prime z plus x z is equal to a prime y prime z plus x y. This is one of the additional algebraic laws from last time we learned. Let's simplify the sum of minterms m1 plus m3 plus m5 plus m6. Let's put it right here. Blah, 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 blah. Oh, okay. So sorry guys, we are at the end. So let's have a quick recap of what we did. We did all of that. Application linear algebra, as we did before. We learned about MSP. We learned about literals, secret-wise, the minimum and the value, and what we choose and what we do. What is the best for the K-map. So have a great time guys, okay, be safe and wear a mask. Goodbye.